Good afternoon. Welcome to Immb International Webinar. I'm delighted to introduce our guest speaker, Dr. Weidner, our UiTM Fulbright Specialist 2024, who is now with us physically today at UiTM Sungai Buloh campus. On a side note, we welcome Dr. Krista Hans, a forensic entomologist from Purdue University, who is also with us today. Great to see both of you here. Now, a few quick housekeeping notes before we begin. This webinar is being recorded and will be made available to all after the session on our YouTube channel. And our YouTube channel is called Immb Medic. If you have any question during the presentation, please feel free to submit the question using the Q&A panel. Dr. Weidner will address them during the Q&A session at the end. Alternatively, you may switch on your microphone during the Q&A session and ask the question directly to Dr. Weidner. We kindly ask that you keep your microphone muted throughout the session to minimize background noise. Now, I would like to introduce Dr. Weidner to all of you. Dr. Weidner is an assistant professor of forensic entomology and a lab director of the Forensic Entomology and Wildlife Laboratory in the School of Interdisciplinary Forensics of Arizona State University. She obtained her bachelor degree in forensic science with a focus in molecular biology from John Jay College of Criminal Justice, followed by her PhD in entomology from Rutgers University in 2016. Dr. Weidner is currently the president of the North American Forensic Entomology Association, or called NAFIA, and a diplomat of the American Board of Forensic Entomology, ABFE. And she's been one of the 23 certified in North America. Dr. Weidner works in forensic entomology, has been published in various journals, including the Journal of Forensic Science, Journal of Medical Entomology, and Forensic Science International. She has presented her work at local, regional, national, and international conferences, both in entomology and forensic background. So her title today is Decomposition in the Sonoran Desert, Discovering the Challenges and Needs in Forensic Entomology. So without further ado, please welcome Dr. Weidner. Over to you, Dr. Weidner.
Thank you. So I hope everyone can hear me okay. That was a great introduction. Thank you so much. So as mentioned, today I'm going to be talking to you about what decomposition looks like in the Sonoran Desert and go over a couple of the challenges that we've seen and the needs that we're finding for this field. I do just always like to start that just a brief heads up that there is some graphic images in this talk. They will be limited, but they will be there. I'm going to skip this because I had a wonderful introduction. So going into what is forensic entomology. When we talk about forensic entomology, we're looking at the use of insects and other arthropods in legal investigations. And as you can see here on this slide, we're mainly focusing with flies and beetles. There are a variety of them. They come at different points throughout the decomposition process. We also can use different types of insect artifacts. So on the top left there, what you're seeing are actually skins or molts from dermestid larvae. So when we take a look at the field of forensic entomology, I'm going to go over 3 different subfields here with a focus on the last one. So we'll review stored products, urban entomology, and medical legal entomology, just to introduce you so you can see the different ways that we'll use these insects. When we're referring to stored products, we're talking about insects that are infesting food that is stored in some location, whether that is in your home, in the warehouse where the products are being manufactured, or sitting on a store shelf. And typically the main kinds that we see that are being infested are grains, flours, or oats, so that dry material, or you can have those fruits and vegetables that are overly ripe and pulling in those flies. When we refer to stored products, the main types of insects we tend to see here are different types of beetles, flies, and moths So pantry moths are a pretty common one. And this really doesn't have anything to do with filth. It just has to do with a nice dry environment where they can raise their young. When we talk about urban entomology, we are referring to the insects that you don't want to necessarily see in buildings, whether that is your home, your workplace, or anywhere you are going. So here we have termites, ants, cockroaches, and bed bugs. Those are some of the images that I have here. And I'm just quickly going to go over a few examples of how we would use this in a forensic sense. So if we take a look at the images here, the left and the middle, this is actually termite damage in the United States. So these are different wood panels on buildings. And you can see that there's excessive damage based on how the termites are feeding. So they're normal biology and ecology. And how we would use that in a forensic sense is, say you recently bought a home from someone, you've been there about a month, and you're deciding that you want to renovate, right? So you're going to knock down a wall, make some changes, and you see extensive damage like this. The question then becomes, how long has the infestation been there? So how long did it take them to cause this damage? So we would go to their biology and ecology and see the size of the colony, how long it would take them to make this damage, and pretty much work backwards. And then it becomes, did that infestation occur before you bought the home or after you bought the home? And if it was before you bought the home, how was it missed in the inspection? Did the previous homeowners know? And then my last image here on the right, if you see, this is a female who went down to Florida in the United States. I'll have a map later in case you're interested about locations, to model. And while she was at a hotel, she was bitten by bed bugs. So those bumps that you're seeing there, those red marks, those are bed bug bites. And you can commonly see that triangular shape. That's pretty representative of them. So she claimed that she could not do her job because her entire body was covered in these welts, and she was down there to take photos in various outfits. So these are both examples of civil investigations. There was nothing necessarily criminal going on in these, right? The termites were just there. They took advantage of that. The bed bugs were just there, and they took advantage of her being there. Now we're going to shift to medical legal entomology. And this is when we're talking about criminal investigations, and it's directly used by law enforcement. And the way it's commonly used are in death investigations or abuse and neglect cases. And when we tend to look at abuse and neglect cases, we see this with animals, the elderly, children, or mentally handicapped individuals. So animals are people that tend to not be able to take care of themselves. Now, why do we care about this insect evidence? What information can we get from them? How long remains have been there or in an area is one of the main questions that we will answer. If a body has been relocated, so if the remains have been moved. We can also look at the presence of drugs or toxins in the insects. And also, a lack of insects can provide us with information as well. So now that we know there are some questions that we can answer, why are they so beneficial? Insects can arrive very quickly to remains. And when I say very quickly here, within minutes. And then within that hour span or however long after, they can begin to colonize. So it's happening very quickly. And they're found globally. We can find these insects pretty much every point around the world, not Antarctica, but for the most part, everywhere globally. And one of the things we're really interested in is time of colonization. And the reason they are so valuable for time of colonization is their holometabolite, which means they undergo complete metamorphosis. So they have discrete life stages. And their growth is temperature dependent. So the warmer it is, the quicker they develop, and the cooler it is, the slower they develop. So what can these insects tell us? I'm going to go over 3 questions with you today: where, how, and when. So here is a map of the United States, and each initial of the letters that you're seeing there are the different states that we have. So if you take a look down here, so where those flies are, that's Arizona. That's where I'm currently located. So in this example, we have 2 species. one that is a green color and one that's kind of a bluish green. And now up north in Montana, we have that bluish green species and a black species. So what that tells us is that blue-green species is widespread, right? It's in northern populations, it's in southern populations. But the green species is restricted to the south, and our black species is restricted to the north. So an example of this would be the black species prefers cooler temperatures or perhaps higher elevation. So now if we're up north and we discover a body and there are insects on it, and they rear those insects out, and this is the species composition we get, what that indicates to us is that the body was not from that area. It was not from the northern portion because we have southern species. So that would indicate that the body came from a southern location, and that could impact how they're going to investigate that case. How? Now, as I mentioned earlier, the insects will arrive very quickly, and they have specific colonization patterns. They will tend to colonize, and what I mean by colonize is lay eggs if they're certain types of flies, or lay little larvae if they're other types, but they look for orifices. So think about the orifices or openings on the face, the eyes, ears, nose, and mouth. They're looking for moist, protected areas to lay their eggs or their young. And from there, they'll hatch out, they'll begin to feed, and then they'll work their way down the body. So they'll be in that head region, shift down to the chest and torso, and continue onward. However, if there are wounds or trauma present, you're going to see a difference in the colonization pattern. So if you take a look at this image here, if you see to the right of the screen here, this pig had an anal prolapse, so trauma to the anal region, and you have a heavy infestation in that portion of the pig. There was colonization in the head as well, but there was a substantial amount towards the posterior end. This would indicate some type of trauma or wound because the masses are not connected, indicating that there's some type of new moist protected environment. Now, this is the question I think we get asked the most, at least me personally, how long have the remains been there? So what we're really looking at as forensic entomologists is the time of colonization, or how long have the insects been there? And the reason we like to make this distinction is if you take remains and you freeze them, for example, and you put them in a freezer for 2 weeks, no insects are getting into that freezer, so they can't account for that. But we can tie this back to what we call the minimum postmortem interval, and that is the period between death and corpse discovery. Sometimes these times are very close together. Other times there can be large time distances between them. When we're looking at time of colonization, the way we do this can be one of two ways or a combination of them. We can look at dipteran larval development. So those insects that I had mentioned, right? Those flies are coming, they're laying their eggs, and then the larvae are rearing or growing on the remains. So we can look at their development. If substantial time has passed, we can look at insect succession data. And these are the arrival times and patterns of those insects that are utilizing the remains. And sometimes we use a combination of both. Just to give you guys an overview of what types of insects we see, I won't be going into too much detail about all of these today, but as I had mentioned earlier, flies and beetles tend to be the main insects that we run into. So just some examples here are blowflies, flesh flies, houseflies, cheese skippers, coffin flies, and drain flies. Most of them, so the top 3, arrive early in that decomposition process. Coffin flies and drain flies more have to deal with decaying organic matter. Cheese skippers can come a little bit later on. And then the beetles that we have here, they will come throughout the decomposition process depending what those remains look like. So some of them are there to feed on the maggots or the larvae of the flies. Others are there for dried tissue and remains of the body. But what I'd like to go over with you is blowflies and their life cycle and how we utilize them. The blowfly life cycle, as I had mentioned earlier, they undergo complete metamorphosis. So they have discrete stages. So they have the egg, they hatch out into larvae, and there are 3 stages within the larvae. So basically they'll feed and molt, just keep growing. They'll pupate, and that's where they're transforming into these adults, and then they'll hatch out. So that pupal stage is equivalent to like a chrysalis for a butterfly. And what we do is we look at their development and we work backwards. So knowing the temperature and information of our scene, we see how long it takes those insects to reach that development stage, work backwards to determine when they were deposited there. That's the quick overview of that. So before I shift into some of the findings and research, I wanted to bring back a map of the United States. So again, I'm in the bottom left over here. So it's designation 10. So if you take a look at that, when you look at all of the United States, and there's Canada, there's North America in there as well. But if you look at the United States, you'll see that green color and that beige color. That's almost 2/3 of the United States. And we do not experience that type of environment where I am located. So down in Arizona, specifically the Sonoran Desert, we experience extreme heat. We can reach values of 49 Celsius for several days in a row for our highs. And we have very low humidity. So 30%, we can drop down to about 15. It's very dry. But we do experience biannual monsoons. So twice throughout the year, we'll get very short durations of heavy, heavy rain, probably what you guys experience here daily. Very rare for us. But we do get that. But since the ground is so dry, we get flooding and blooms of things we haven't seen in a long time. But for the most part, it's very dry and it's very hot. So I got to Arizona in 2019. And the first thing that I wanted to investigate was, what did forensic entomology look like in this state? So the 2022 through 2024 are just some publications of forensic entomology work since I've been there. But prior to getting there, these were the publications relating to forensic entomology and blowflies. They occurred from 1935 to 1985, and they were really looking at filth flies associated with urbanization, slaughterhouses, livestock, and blowflies just happened to be included. The one that has the asterisk or the star was an unpublished thesis that did look at some decomposition, but that was in the 60s. So basically this information was non-existent. But what I did notice, what we were able to determine, was there were 10 species of blowflies that were collected throughout that duration. And in 1982, there was a new record of a species called Chrysomya rufifacies, which you guys do get here as well. It had just started to make its way into the United States. And that 2024 publication is actually us confirming their establishment in Arizona. They've made their way up. They're migrating throughout the United States. And what's really unique about them is their behavior. They can be both predatory and cannibalistic, especially if their food source dwindles. So just a little overview of my lab. The main type of work we look at is blowfly biodiversity, insect colonization with our decomposition, blowfly development, and we're really interested in larval morphology. What I'm going to speak with you guys today is about blowfly biodiversity in the area, how we kind of worked through this, some trends that we were seeing, and insect colonization. So taking a quick step back, there are some basic needs in the field of forensic entomology, just like there are basic needs in any field. You first need to understand the distribution information, right? What are we seeing when? How does that tie into season? How does that tie into habitat when you have different elevations, different environments, and developmental information once you know these? Forensic entomology in the United States has been utilized since about the 80s, but we are still missing a lot of basic information. So what I'm going to address with these studies are these first two. And I'm specifically going to focus on blowflies. So like I had just mentioned, basic question, what species are found when? And I think this is a great transition point, because when I got out to Arizona, I had an attorney reach out to me about a case, a cold case, and he said, can you tell me if these flies were supposed to be in this area at this time of year? You would think that was something we'd be able to say, yeah, sure. I said, well, that's a great question. I don't know. Those surveys, I'm a super strong proponent for surveys. And what that is you put some type of baited trap out. So these are just 3 examples of different ones that I've used to collect flies or other insects in the area. And they don't need to be expensive. The one in the middle was like a Ziploc bag with a cone trap, and I put some binder clips on it. We made do. The others are manufactured that way. So ultimately, we're putting these baits out and seeing what flies we're getting. So the first study that I want to discuss with you guys was when we had done our survey at Arizona State. So this is in Phoenix. This is a very urbanized, hot heat island in the area, and there was no published work on this. So what we did this for a year. We wanted to do it for 2 years, but if you notice the date, 2020 hit, COVID happened, that project had to cease. But it was very simple. So we had 4 traps, and if you can see the red triangles, those are where we place our traps out on campus. And those ranged from about 300 meters to just under 1,200 meters. We placed our traps out weekly, and we put in 60 grams of bait. And now we initially were looking at different bait type here to see if there was a preference. So BL is beef liver, PL is pork liver, CL is chicken liver, and then ML is mixed liver. I took 20 grams of each and just smushed them together. And we rotated the location each week. So we moved where the baits were going so we could say that we were collecting throughout the campus with the different baits. And we kept them out for 24 hours. And one of our main reasons for that was in the summer, after 24 hours, that meat basically cooked, dried up, wasn't very useful after that. But this is what our traps looked like. They were very simple, very cost-effective, easy to use. We had our bait, which is in the bag, a gallon Ziploc bag, that cone trap on the top. I had put a paper towel in because when I have used this trap in the past and the environments were not this dry, the meat would get kind of juicy or had fluid build up, but we ended up not needing that. And then we had the binder clips, and that was it. And all we did was hang them around campus. So after a year, these were our first initial findings. So we had 8 species of blowfly. And if you take a look here, we had 3 that were really predominant on campus. So Califera latifrons, Lucilia sericata, and Lucilia mexicana. And what's really interesting about this is if you go to the literature, Lucilia sericata is studied pretty well. It's a common fly species that we use. Califera latifrons has 2 development studies published to date. Lucilia mexicana has none. So we are now seeing these predominant flies with very limited data. Now this is the relative abundance, so the looking at the numbers of our flies over the different seasons. And what you can see here is blue is sericata. So sericata was our main fly or our only fly in the summer. And then if you look at fall and spring, you're seeing pretty similar trends, right? The majority was sericata, then we were followed by latifrons and mexicana, whereas in the winter, latifrons became our predominant fly there. But now here are the values of flies. And this is something I think is really important because in the summer, we only caught 2. That was it, 2 adult flies. Whereas in the spring, we had caught just over 800. And this was really surprising. So I'm not from Arizona. And in my mind, I was like, summer, this is going to be the best time. We're going to get so many flies. And we were learning that the temperatures were just so extreme. So if you take a look here, you can see our temperatures. So temperatures are on the right. And then you have the average number of blowflies that we had caught in our trap. And if you take a look, so the month is on the bottom. So we're starting here with June and July. Our numbers are so low. We don't actually see pickup until the following spring. So this was very new to me because where I had lived previously, no flies were in the winter. It was too cold. That was like our down season. And it's the complete opposite here. So it led to the question of how hot is too hot for these insects, for these flies? So just at the end of this survey, we were also conducting a wildlife forensics decomposition study where we had placed a calf carcass outside. So the image on the left is a normal standard image. The image on the right is IR, so an IR camera. And what we saw here was the ambient air temperature was 28 Celsius, but the surface temperature of our calf carcass was hotter than 55 degrees Celsius. So you see it has that black fur. So it was really just absorbing all of that solar radiation. And that was really interesting because we weren't seeing the normal colonization. They had gone into the body And we didn't notice that until we had a little mini monsoon roll through, and the fur and the skin sloughed off, and there were thousands of maggots inside the body. So this was really interesting because we wanted to look at insect arrival and colonization. How are they taking advantage of these remains? So when we talk about a time of colonization, we are making several assumptions with that, right? That colonization is going to occur shortly after death. We know that they can arrive very quickly within minutes. And that is assuming that the body is exposed, so it's unhindered, it's not sealed in something it's easy to get to, and that colonization is occurring during the day. So typically from the literature, there's some mixed reviews, but for the most part, we don't see blowflies or flies colonizing during the day. So this led to us focusing on the time point from when the remains were exposed until when they were colonized. And I just quickly want to go over this table to kind of explain where we're focusing on this. So if we take a look, this was from Tomberlin et al. In 2011. And what we're really interested in is that pre-colonization interval. So prior to colonization, how much time is taking place there and what's going on? What are we seeing? So this led to our first very lengthy, very long decomposition project in Arizona. And these were our questions. We wanted to look at the initial insect colonization and try to understand, does extreme heat in a very dry environment delay our initial insect colonization? And we want to look at the insect succession patterns across different seasons. When we have these really dry environments, is it affecting what we see for a typical succession pattern? So when we look at our succession pattern, we have our flies, our specific beetles as we move through the process. How is that impacted here? So if you take a look here for our methodology, I've color-coded our trials. So we did a 3-week decomposition process in the spring, summer, fall, and winter from 2021 through 2022. And we put 2 pig carcasses out per season, and they range from about 23 to 40 kilograms, and they were out for 3 weeks. For the first 10 hours, we checked on them every 2 hours. After that point, we shifted to 8-hour checks for the duration of the 48 hours. And then after that, we had daily checks through our 3 weeks. Now, when I say check, what do I mean by that? So we photographed our remains. We did the standard 4 sides around our remains. We also did IR images. We completed adult insect collections. So this would be through sweep or hand collections, depending the type of insect. We also took temperature measurements. So ambient air temperature, the surface of the remains, our interface temperature, so where the remains met the ground, and if there were any maggot masses. In addition to that, we did egg and larval collections and pitfall collections. So at a family level, I'm going to focus on the flies. That's what my focus usually is. I wanted to see what were we just seeing for our main types of insects. And now this is just their presence. It means that we caught them as adults. So from family level, we had our blowflies, we had our flesh flies, we had so many houseflies, especially in the summer, and we had cheese skippers. So those go across from top left, and then, sorry, these are not in order. Top left, these are our blowflies. Bottom right is our flesh flies. House flies are top right, and then our little cheese skippers are down here. And what was really interesting was that there was no muscid or housefly larvae collected during any trial in any season. And in the summer, the adults, we caught hundreds of them. So it was really frustrating that they were around, but they weren't even colonizing. They were just there to land on us and annoy us. So from this, I want to take a little bit of a deeper look to our blowfly species, right? So we had done that survey. How does this kind of compare with that? So in the spring, we had, again, this is just the presence, so what we collected as adults: Chrysomya rufifacies, Cochleomya macellaria, Mucilia sericata, and Formia regina. In the summer, we had rufifacies and sericata, and if you remember from that survey, we had only captured sericata. In the fall, we had those same 2 species with the addition of macellaria, and in the winter was when we had the most species we experienced. We had Califera coloradensis, Polyphral latifrons, back to Rufophaces, Macellaria. Now we had 2 additional Lucilia species, Coprina and Mexicana, and Regina. For our flesh flies, they are very challenging to identify down to species, so I kept them at family level here. We did capture them every season. So now what I was interested in, taking it one step further, we have these flies that are around, but who's colonizing these remains? Who's taking advantage of them? So the bolted species here, we had larval collections. So we collected them from the remains. So you can see Chrysomya rufophaces, Cochleomya macellaria, Lucilius ericata, and then all of them in the fall, so the same type there. So spring and fall, we had very similar species colonizing, interactions. The summer, both of them colonized. And in the winter, we just had a handful of those initial species colonized. And if you see down for our flesh flies, in summer and fall, they colonized as well. So if you remember, I was talking about the initial arrival of these insects. When are they coming to the remains, and how is that working? So if you take a look here, I've split it out by season, and I'm looking at the initial arrival. And what that means is we saw flies. We saw adult flies in the vicinity that landed on our pigs. They weren't just in the trees around. They had landed on our pigs. And colonization here, the definition we mean are eggs or larvae. So the eggs had laid and they hatched out, or flesh flies had laid down some little tiny larvae. So if you see here, when I say immediately, which I'm saying for spring, fall, and winter, we would go out. So we had our pigs in bags. We would bring them right out to the field and drop them. If by the time we were done setting everything up, taking our collections, we had flies, we considered that immediate interaction. For colonization, that means that we collected eggs that successfully hatched out, or small larvae from flesh flies. So now what I have here, I'm going to put in a figure format. Figures just work a little bit better for me. If you see here, we have all of our seasons. And now if you remember, I had mentioned that our initial checks were every 2 hours. So if you see spring, for example, colonization occurred between our 4-hour check and our 6-hour check. So there were no eggs when we checked at hour 4, but there were eggs when we checked at hour 6. And if you see winter, colonization occurred within the first 2 hours, or 4 to 6. For fall, we saw a difference between our pigs. So one pig was colonized very quickly, and another one was colonized later on that day. But what I really want to draw your attention to is the summer. So you will see here that I have solid bars, and then I have ones that are a little bit lighter or outlined. And what happened was we had seen eggs at both of those points where you see the light pink, but they never hatched out. So they wouldn't have been useful in a forensic sense because they never hatched out, and we wouldn't be able to determine when they were laid. And if you see, there's quite a large gap in between the bottom line and in the second line, we got them on our next 8-hour check. But what's really interesting here is something I had said earlier. Flies arrive within minutes, they'll colonize within the first couple hours. That does not hold true, at least in this situation in our summer. Those dotted lines that you're seeing, the first one is 24 hours after placement. So for the summer, we have not had successful colonization by 24 hours. For our 48-hour mark, it occurred within that 8-hour window. So potentially just prior to 48 hours or just after. And that's almost a 2-day delay. And that's really important because what we're seeing here and what we're looking at, it's not holding true necessarily to what we are saying with our common assumptions of they're arriving really quickly. When we have those hot environments, you can see here in our spring and our winter, they're colonizing within 6 hours. That's great. Fall, we have one that occurred quickly and one that occurred around that 24-hour mark. So we're starting to get that temperature shift. So we're coming from really hot, right? Starting to cool down. So what are our conclusions from this? So we have our initial colonization that occurred within those 6 hours for 3 of our 4 seasons. So that's supporting what we're commonly seeing. However, when we get into those summer months, we had more than 24-hour delay for both of those pigs. And this is violating several common assumptions in forensic entomology. We did notice, though, that our predominant colonizers were the same for fall and spring, like we were seeing. And if you think back to that initial table, a lot of the species that we were collecting within our survey were what we were seeing at our remains. But very interestingly, Chrysomeyer rufifacies was not collected in our survey, but was on our remains as one of our predominant colonizers. And when you talk about this species, it can be known as a secondary colonizer. It's coming in a little bit later. This is the species that is also predaceous and cannibalistic on other larvae. So the baited traps might not have been an ideal situation for this, but in the same area, an entire remain can be of value. So what does this lead to for our challenges and our needs? So we see that these hot and arid environments do not follow these basic assumptions. And one of the things I didn't get into too much detail here about had to do with the insect colonization and the order of arrival or the faunal succession for which these insects are coming. So there are a type of beetle known as a rove beetle, for example, that are very common. We're always seeing them. They're feeding on the maggots that are on the remains. And of all of our decomposition, so our 4 seasons or 8 pigs, we did not catch a single forensically relevant rove beetle at all. They are not common in desert environments. And another type of beetle that we commonly see is our burying or carrion beetles, and you will see the adult and the larvae at the remains. Again, for our 4 seasons, 8 remains, we never captured that beetle, so we're not seeing it in these desert environments. And that's really important because when we talk about faunal succession and how these insects are arriving, you'll be expecting them, you'll be looking for them, but we're not finding them. Our dermestids or our skin beetles, as their name suggests, they're feeding on skin or dried materials. We commonly say that they arrive later in decomposition towards the end when things are starting to dry. But in the desert, where it's very hot and very dry, mummification of remains can occur very quickly. And we were seeing dermestid beetles as early as 2 days after the remains were out. So if you're trying to look at these timelines with the expectation that those beetles are arriving later, you're going to see that can be misconstrued. What we really need, and I think I can say that this is a need pretty much everywhere, is more work investigating initial insect arrival and the behavior in these environments. So even if you have these insects coming in, if the surface temperature of those remains are too hot, they're not going to colonize, right? Because that's a pretty good indication that their larvae are not going to survive. So where they're colonizing can change. One of the things we noticed in the summer, rather than laying in those orifices, like I had said, they're common areas they go to, they were actually laying on that interface. So along the stomach of the pig where the ground was, because it was the coolest portion, it was shaded. That was the best for them. But when we see these different environments of different humidities, different temperatures, different just environmental areas in general, understanding how the insects are interacting with these remains prior to colonization is really, really important, because that's pretty much our unknown, right? When we start our calculations, we're looking at, okay, the eggs were laid, but what's happening before that whole situation? More observational studies, and I feel like this is a little bit controversial because people want statistics and they want those numbers, but just observing what is happening is so important. How many times do you run across a paper that it was just something you saw in the field, so you wrote it down, and now maybe you're seeing it, or maybe you're unsure if that's common? Observational studies, and these are great for undergraduate students, graduate students as part of their work, because you need to understand what you're seeing, right? The numbers are absolutely important, but understanding how these insects are interacting is integral in this field. Investigating thermal limits. So this is something I have been interested in when we saw that the insects weren't coming. How hot is too hot for them? So there's been some work on this, seeing what their thresholds are. In the field of forensic entomology, we look a lot at lower limits because we use that for some of our calculations, understanding where the insects are if they're not present. But we need to understand if it's too hot for them to be colonizing, and what are those limits by species? Is that going to differ by where they are in the world? So that's really important. And we need more work, specifically taxonomic, on flesh flies in the United States. We already have our struggles with our larvae of blowflies. We have really great taxonomic work on the adult. And in other portions of the world, there's some really great taxonomic work on flesh flies, adults, and larvae. But in the United States, we really need to start focusing on that, especially if in certain environments, we're starting to see them as being our main colonizer, or they're coming early, they're utilizing those remains. So that's really, really important. And this is, I say, definitely for where I am located in these hot and arid environments, but a lot of this work can be applied globally, all across the world, in different countries and different areas, because there's so much basic information that we still need. So with that, none of the work that I did would be possible without my lab, without my team of students. So where I am located, I'm actually an undergraduate only program. So I had a team of undergrads for this decomposition process. I mean, when it was like 46, 47 Celsius and we were out there with these pigs, nobody wanted to be out there with these pigs, but they were just amazing. And there were so many of them over the course of a year. So with that, I can take any questions, and thank you guys for the time.
Thank you so much, Roland, for your insightful presentation. Sorry, I was muted just now. All right. Okay, thank you, Roland, for your insightful presentation. All right, now is Q&A session. For our online participants, you may post your question in the chat box, and I will be happy to read it for you. Alternatively, later you can also switch on your microphone and ask. And by the way, we do receive one question from the online participant, and it is from Professor Nataraja Muti. So Professor asked, he said that this is very interesting study, and congratulations to you. And he asked, have you ever seen any real death investigation in the desert area of your study?
Yes. So I've been working casework in Arizona probably for the last 4 years. The first year took a little while, but I have absolutely seen some human remains. And what we're looking at with the majority of the cases I have, they are mummified. I should say in the summer specifically. I deal a lot with mummified individuals unless they're in an indoor situation. If they're in an indoor situation with more regulated temperatures, they tend not to mummify as quickly. But in the actual desert, we are seeing mummification very quickly. And one of the things we're doing with the research that I presented here, we're comparing our survey information to our decomposition project to our human remain cases. So we're seeing how all of the information compares across all three.
All right. I hope that answered the question of Prof. Nataraja. All right.
Thank you, Dr. Chong. Thank you.
You're welcome. Okay, if there's one more question from Abdul Hadi, and he asks, insect colonize faster in winter than summer?
So yes, where I am, they colonized quicker in the winter, and that is most likely due to the temperatures. So when our winter temperatures are probably around like 20 Celsius. Sometimes they get a little cooler, but it's a fairly nice temperature. And the humidity is a little bit higher. So in Arizona, the colonization occurred quicker in the winter. In other parts of the United States, as you get more temperate and you go east and north, that would not be the case. Sometimes it's too cold for colonization, or they would colonize quicker in the summer months.
Yeah, it's very interesting observation. Yeah. Any more questions from our online participants? All right. Is there any more question? Is there any question from our physical audience? You may ask as well. Yeah, please, Mohammed. Yeah. All right.
Sure. So
The question is about the invasive species in Arizona, right? Yeah.
I should unmute myself. Thank you. So Chrysomeria rupifacies is actually considered an invasive species because it came up from south and has expanded. As far as other invasive species, we don't necessarily see them in human remain cases. That could be more of when we have transported goods throughout the state, but they don't tend. So what gets tricky is we have our different states in the United States, but insects don't care about state lines, right? They're going to move however, and if they find a new environment and they're very happy, they're staying. I can't think off the top of my head of a forensic case where that was utilized, although there have been situations where the different species where they're commonly found, that they've been transported with people or on vehicles to help determine if a vehicle has been in a specific location or not. We haven't had too many issues with invasive species. The only one I'm currently thinking about is the imported red fire ant. People get very, very panicked about bringing that in or over. But it's tricky to keep them within different geographical regions since our state lines, we don't have large waterways that are separating a lot. But one of the things that does happen with our invasives is they're moved often with timber or like firewood. So when people go camping, we have a very big issue with that. But again, I haven't seen that in a forensic context. Good question.
Thank you. There's one more question from online participant. How thermal images help in your investigation?
So the way we use thermal imaging here is we are trying to see what impact that's going to have on our larval development. So if you recall, I had said that development is temperature dependent, right? So the warmer it is, the quicker they're going to develop. So taking these temperatures, and thermal imaging is just a nice way for us to visualize it while capturing that data. But in the SOPs, for example, or the standard operating procedures and protocols that we give law enforcement, we ask them to take those collections for the maggot mass temperature, for example, because if they're generating enough heat, it's going to increase their development. And that's important for us to know when we're calculating a time of colonization. So for example, I had a case where the remains, I have to translate this to Celsius now, the remains where they had done just kind of the body, it was about
How many Fahrenheit?
Fahrenheit, the bottom. So the first collection was like 90.
Close to 40.
Okay, close to 40 Celsius, but then the maggot mass was 113. So like 40.
40 plus, yeah.
Okay, yeah, 44, around a little bit higher. So we're seeing sometimes it can be substantial. And if the body is in a cooler environment, so the surrounding air temperature is very cool, but the maggot mass is generating this heat, they can continue to develop at a decent pace. So thermal imaging is just a really great way to capture the temperatures and see where those heat spots are. Good question.
All right. Any more questions from the audience? There's one more question. Nurul Aida. Hi, doctor. Do you observe ants in your study? Mm-hmm.
So do I observe ants in my study? Oh, yes. Ants can actually be a very huge problem. In this study specifically, we actually saw, I think, 5 to 6 different types of ants. They weren't a hindrance in this study, but we have seen examples of them carrying maggots away, carrying eggs away. And sometimes, depending on where remains can be, ants will they don't colonize, but they'll walk over and take little pieces of flesh, and it can actually hinder blowfly colonization. So if you're in an area with high ant populations or the remains just happen to be near ant mounds, that can absolutely play a negative role on the forensic entomological work. That's also a great question.
Yeah, you can ask. no larvae found during? Oh, the Musidae. No,
Yeah.
no, yeah. The question is about no larvae of the Musidae. Yeah.
So that is a great question, because when we initially were there, when I say they were there by the hundreds and landing on us, and I was like, all right, they've got to be colonizing, and they weren't. I actually reached out to someone who works with houseflies because I was unsure myself. The adults are there, they're using the body for fluid, just for moisture. So it doesn't necessarily need to be remains, but all of a sudden you drop out something that has a high fluid content in the desert. So they're just taking it for fluids and salt and not anything to do with laying their eggs. Yeah, it was fascinating and annoying all at once.
Okay. Yes, please.
I think what we should help the saying so I think it pertains to both. I have to remind that what happened to real estate agents on the right so real estate. And when I got to the renovations stage, I got to this couple of ways why it was criminally relied in this state.
So you're talking about like a termite infestation in the home?
Yeah.
Or so it's. Did you want to repeat the question? Yeah. Or so the question, and let me know if I didn't get it right, was if we had bought a piece of real estate and there was an infestation they found during renovations, who would be criminally responsible for that, liable for that? Oof. So how you would use that is we would want to see, based on the size of that colony, how long it took for them to reach that. And that we can do by looking at normal biology, reproductive traits. And then you have to work back for the time. So then it becomes, if it was prior to you buying it, and we can confirm that, then it goes, if the previous homeowner knew, and I'm trying to think who it would necessarily be, because you would have an inspection and they should have caught that if there was. So I'm not the best with legal aspects necessarily there. So I'm not sure who it would fall to. I think it would have to be if you could show if the previous homeowner knew or not. So I can't really speak much beyond that, but that's a good question.
Yeah, one more question, please. It's about the climate change effect on the insects.
So I absolutely do. We've been looking at work. So specifically where I am, like I had mentioned, it's an urban heat island, and the rate at which the temperature is going up there is alarming. But what we're seeing is the distributions and the migration of these insects. So they're moving. So some of these warmer species that we're mentioning, we're now seeing first records of them up in Canada, and they're slowly starting to move. And the invasive species, for example, Chrysomya rufifossés, it's pushing out those native species. So if you actually have remains and we have that invasive species, the other maggots will partition away from it and they'll go onto different parts of the body. So as we're seeing these increased temperatures, we're absolutely seeing these migration, these distribution expansions, and that's going to play a role with those insect interactions.
So you do have data spoken about, I mean, not necessarily forensics, but insect migration caused by temperature. So we have data.
So there's certain data for certain species. Niche modeling is a big one, looking at where they were. So this can come from museum specimens or data, looking at a certain time, correlating it to the temperature, and then you can even do predictive modeling and then moving forward. It's actually part of a grant we're putting in for right now. So great question.
It's one question from online. Do you encounter carrion beetles in your study?
So for this specific study, I did not encounter a single carrion beetle. There was none. We do get them in northern Arizona, think like forested areas. So there's a little bit more humidity, more coverage. But in the desert, we did not get a single carrion beetle. And I love carrion beetles. I was looking forward to them. And we didn't get a single one.
That's too bad, right? Right. We have 5 minutes more. Yeah, Dr. Tanya Ivora. Yeah.
So-
Yeah, the question is about the temperature in Arizona.
Okay.
Yeah, it's all right. It's all right.
The
Right, Rory is going to pull out the slide. Yeah. So what's the temperature in Arizona? I mean, fall and spring. Is it big difference or very similar? Very similar.
That's why I wanted to show that figure.
Mhm.
I've reached the point where I can't do technology. Thank you. So I will pull up, I don't know how to see all of them. We're just going to power through everything really quick. So it's set up a little bit differently than mine. Sorry about that. Where are all of them? Okay, took us long enough. There we go. So right here is where we have our fall. So our average temperature is about between 25, 30. Same in our spring, 25. Our happy place for our flies per se is really about 23 to 28 is what we're seeing in our fall. I think when we looked at the data and analyzed it, there was no significant difference in our actual temperatures during those times. Oh, to other parts, absolutely. Yeah.
Usually on winter is like all the month.
Yeah, no, that's why I was really surprised when we had our highest species richness in the winter and we had those clipper species coming through. So yes, that is our most diverse time.
All right, we have 3 more minutes. Yeah, any question from Dr. Choi? Yes. Yeah, the question is about the buried cases. Would you expect to see any other insects? Yeah.
So we did bury some rat carcasses in several different areas. In the desert, we had coyotes that dug them up, no problem, and took them. But we actually saw with buried remains more involvement from flesh flies. So we buried them about a foot down and they were able to be colonized. I would expect that, so when we deal with buried remains, we usually have some types of beetles. It also depends the depth of burial. But ultimately, if it can be scavenged or not, we would definitely see a reduction in the number of individual insects that we're seeing. But there would probably be a transition, like I had mentioned, we had mainly seen flesh flies. So we would see a shift in what is colonizing or what our predominant colonizer is. Thank you.
Okay. Do we have any more questions? No? Last call? Anyone? No? All right. Okay, I think due to time as well, I think we can conclude our webinar today. So thanks to Dr. Roland Weidner. Thanks again for your presentation. And I would like to thank all the participants that joined us today. So before we wrap up, please fill in the attendance form because the training hours will be recorded for UiTM staff. And if you have any other questions for Dr. Roland Weidner, please feel free to reach out to us or email the speaker directly. I think you can easily got her contact email address just by Googling her name. So thank you once again for your time, everyone. And we look forward to having you join us in our future event. Goodbye and take care, everyone. Bye-bye.